Okay, we're going to solve a series of trigonometric equations here. The first one being 2 sine theta plus radical 3 equals 0. And we are also told that theta is in between 0 and 2 pi, meaning that our answers can be in the first, second, third, or fourth quadrant. Now, other thing you should notice is that the sine is not being raised to any exponent like a squared or something, so it'll be pretty simple to solve. The first thing we'll do is subtract this radical 3 from both sides of the equation. Now, the radical 3's, they will cancel out to become 0. We will bring down the 2 sine theta. And 0 minus radical 3 is negative radical 3. Next thing, we will divide both sides by 2. The 2's divide out to become a 1, and we are left with sine theta on the left. On the right, we have negative radical 3 over 2. Now, in order to get our answers for theta, we will look at our unit circle that's here to the right, and recall that sine corresponds to the y values of the unit circle, so we have to look on the unit circle to see where we can get a y value of negative radical 3 over 2, and those two places are going to be in the third and the fourth quadrant. In the third quadrant, we see that at 240 degrees, we have a y value of negative radical 3 over 2, so that's our first solution. In the fourth quadrant, we also see that at 300 degrees, we have a y value of negative radical 3 over 2, so our two answers are 240 degrees and 300 degrees. Next up, we have 3 radical 2 cosine theta plus 2 equals negative 1. Same conditions for theta. Once again, we do not have the cosine being raised to a power of 2. So the first thing we'll do is subtract 2 from both sides of the equation. These 2's will become 0. We will bring down the 3 radical 2 cosine theta. Negative 1 minus 2 is negative 3. Our next step will be to divide both sides of the equation by 3 radical 2. And these 3 radical 2's would divide out to become a 1. We will be left with cosine theta on the left. Now, negative 3 over 3 radical 2, the 3's will divide out to become a 1. So we will be left with negative 1 over radical 2. Now, we know that you cannot leave a radical in the denominator, so what we'll have to do is rationalize the denominator, and we do that by multiplying the numerator and the denominator both by radical 2, and this will eliminate our radical for us. Negative 1 times radical 2 is negative radical 2. Radical 2 times radical 2. If you multiply a radical by itself, we know that the radicals cancel each other out and leaves us with whatever numbers inside the radical, which will be a 2. So our equation is the cosine of theta equals negative radical 2 over 2. What we need to do is look where we have an x value of negative radical 2 over 2, and the first place we see that is in the second quadrant at 135 degrees, so our first answer will be 135 degrees, and the second place we see that we have an x value of negative radical 2 over 2 will be at 225 degrees. So our two answers for this problem are 135 degrees and 225 degrees. Okay, next up, we have 2 sine squared theta minus 3 sine theta plus 1 equals 0. Now, this time, unlike the previous examples, we do have the sine being raised to an exponent. So what we're going to do is rewrite our equation, and we are going to substitute an x wherever we see a sine x. Now, if we do that, we're going to rewrite our equation, and it's going to look like so. 2x squared minus 3x plus 1 equals 0. Now, this becomes a quadratic equation, and the next thing we're going to do is factor the quadratic equation. So in order to do that, we'll write two sets of parentheses because we'll have two binomials that multiply to get 2x squared minus 3x plus 1. So in the first set of parentheses, we'll put a 2x. In the second set of parentheses, we'll put an x, because the only way we can get 2x squared is if we multiply 2x times x, speaking of whole numbers. And for the last term, we have a positive 1. Now, the only way we can get a positive 1 here, however, a negative in for our middle term is if we have a negative 1 and a negative 1. And let's see if this makes sense. We already said that the first and the last terms make sense. Let's check the outer and the inner so we can see what they add up to in the middle. 2x times negative 1 is negative 2x, and negative 1 times x is negative x. Those do indeed add up to negative 3x. Next thing we'll do is set both factors equal to 0. So let's write 2x minus 1 equals 0. And we will also write x minus 1 equals 0. Let's solve both of these. So we add 1 to both sides of the equations. Here we get 2x equals 1. Here we get x equals 1. If 2x equals 1, x therefore has to be equal to 1/2, and we have x equals 1 over here. However, remember when we started, we substituted x for sine x, so this isn't really x, this is actually sine of x, and this is also sine of x. Now what we need to do to solve for x is look on our unit circle and see where we have y values that are 1/2 and positive 1. So for sine x equals 1/2, we can see that the y value where we get 1/2 would be 30 degrees and 150 degrees. So let's write that here. X is equal to 30 degrees, and x is also equal to 150 degrees. As far as sine x equals 1, there's only one place on the unit circle where we can get a y value of 1, and that will be at 90 degrees. So our three solutions are 30 degrees, 150 degrees, and 90 degrees. Okay, let's move to our last equation here. We have cosine of 2x minus cosine squared x minus sine x equals 0. And we have our unit circle here on the right. And notice that we also have, I've written the cosine double angle formula. And the reason why we're going to use the cosine double angle formula is, notice, as comparison to the first few that we did, there's a 2 here. So that constitutes a double angle. What we're going to do is rewrite the cosine of 2x as cosine squared minus sine squared. So what we'll wind up with is cosine squared x minus sine squared x. That's the cosine 2x. And we'll add on minus cosine squared x minus sine x equals 0. Let's clean this up here a little bit. Okay, now the next thing we'll have to do is cancel out this positive cosine squared and negative cosine squared. They become 0. So what we're left with is negative sine squared x minus sine x equals 0. Next up, what we'll do is factor. We have to factor because, once again, we have a sign being raised to an exponent. Now, what we'll have to do, though, is factor out a negative sign, not just a sign, but a negative sine x. Now, when we do that, let's write negative sine x and then a parentheses. If we take negative sine x out of negative sine squared x, we are left with sine x. If we take a negative sine x out of negative sine x, we are left with a plus 1. Now, we have two factors, and we will take both factors and set them equal to 0. So the first one we'll write is negative sine x equals 0. The second one we'll write is sine x plus 1 equals 0. Now, this one here says negative sine x equals 0. And since this side is 0, we can simply divide by a negative 1. So this equation becomes sine x equals 0. All right, these two equations are essentially the same. Over here, we have sine x plus 1 equals 0, so we can subtract 1 from both sides, and that will leave us with sine x equals negative 1. So what we now must do is look on the unit circle to see where we have 0 for a y value of sine and negative 1 for a y value of sine. Now, on our unit circle, there are two places where we have 0 for a y value, and one of them is 0 degrees. Another one is 180 degrees. As far as the negative 1 value, there's only one place on the unit circle where we have a y value of negative 1, and that would be at 270 degrees. So the three solutions to this equation that we started off with are 0, 180 degrees, and 270 degrees.